Okay, this is problem 7.2.1, and we're working with identifying domain and range and working with these graphs right here. I have units of 1 on this graph, so I don't have my units listed, so each hash mark means that I'm looking at a unit of 1. And let's go ahead and start with this problem right here. It says find f of negative 3. So this is function notation telling us that we have an x value of negative 3, and they want us to find the y value that goes with it. Okay, so what we're going to do in order to do that is we need to go to where negative 3 is on our graph. That's right here. And I'm going to go up and find the point that corresponds to it, and I want the y value of where that's occurring, and that's occurring at a y value of 2. So f of negative 3 here is actually equal to 2. Now what you'll notice is this is actually an ordered pair, right? This is another way of representing an ordered pair. So when they're asking for f of negative 3, they're basically saying, hey, we have an x value of negative 3, find the y coordinate that goes with that for the ordered pair on the graph. Okay. All right. So so that would be that right there. The domain is referring to our x values. So we're looking at which x values we have on the graph, where our graph is defined basically for its x values. And if we look at this, we just have singular dots here. And this actually is a dot right there on the y-axis. And so if we were to list all of these points out, let me actually just list them for you. So this is negative 5 and 1, 2, 3, 4, 5, I believe. Is that correct? I think my graph is a little off. This is supposed to be at 3. This is supposed to be at 4. So this is negative 5, 4. It's a little bit hard to copy these off of the computer, but on the problem on the computer, they have them accurate. This point right here is negative 4, 3. This is our negative 3, 2. This is negative 2, 1. That's that point right there. Negative 1, 2. We have this point right here is 0, 3. And this point right here is 1, 4. Okay, so this negative 2, 1 is that point right there. Okay, and I don't know if you can see that. Let me pull it up so you can see it a little better. Okay, so when we're identifying domain, we're basically actually just identifying the x values that are occurring for each of these individual points. And so our domain here would be x such that our x is equal to, and I'll list them from smallest to largest here, so we have negative 5, negative 4, negative 3, negative 2, negative 1, 0, and 1. Okay. So that's our domain. Any x values for which f of x is equal to 4. So part C here. This again is function notation. F of x is the same thing as y. So they're actually again asking us for an ordered pair, but they're giving us a y value of 4 this time instead of giving us the x value. So now they want us to find the x value that goes with y equals 4. So if we go to y equals 4 on our graph, that's 1, 2, 3, and 4 right here, we actually have two values. There's this value right here, so that's at an x equals 1, and there's this point right here, which is at negative 5. So there's actually two different x values that occur at y equals 4. Okay. And the range is referring to our y values, where we have y values. So in set notation, that would be y such that the y is, and we can just read off the y coordinates on our ordered pairs here. And so basically, we have a y equal to 1, 2, 3, and 4. Okay. So that's it on this problem. There's a related problem that I want to do because it's actually helpful to see the difference between this problem and the one I'm going to do. I can talk about that now in the same video. So let's go ahead and do that. This is problem 7.2.7. And the difference between this graph and the previous one, let's talk about that because this can be very confusing to students. This graph had singular points, so it just had, dots made up the graph. This graph has a continuous graph, so it is going off towards infinity in this direction. That's what that arrow indicates, and it's going off towards infinity in this direction. That's what that arrow indicates. And the importance of that is that will affect our domain and our range, how we list that, okay, versus how we did the previous problem. So let's go ahead and take a look at this first one here, f of 2. So again, they're saying to us when x is 2, find the y coordinate that goes with it. So I'm going to go to an x equals 2, and whoops, I forgot to pull that off the graph and see if this is accurate. I believe it's 4. On my graph it's 4. I'm assuming that this would be so, that I copied this pretty accurately from the graph that was given on the problem. And I did mark down this point that I needed. I think that's supposed to be on a grid at 4. Okay, so f of 2 would be 4. This ordered pair point is 4 on my graph anyways. And like I say, in MyMathLab, they give you these pictures, and they are, you can actually see the grid on them. Okay, but when I print those off, they're actually way too small for you to see, so that's why I copy them like this. All right, the domain. So on this one, if we look at the domain, remember the domain is referring to the x values. So we're looking at the x-axis, and we're looking at what values, what values for x do we have on our graph? Well, since this graph continues towards infinity in this direction, even though it's moving this direction, it's actually moving out as it's moving up. So, I mean, it's moving in diagonal, but it is actually moving in both directions, so to speak. So, in terms of the x's, it's actually going to go out towards negative infinity. And this is going to go out towards negative infinity here. So there's no restriction here. We have values coming in from negative infinity, then we have values all the way to here, and again with this arrow, this is taking the graph out to positive infinity, so it'll continue to move that direction. So your domain here is actually all real numbers. So you can either list that, writing that, I didn't leave myself enough space there. You can either write that as all real numbers, just write it out, or if you want to write it in set notation, it would look like this: x such that my x is an element of the real numbers. So an E like that means element of, an R with a line through it means real numbers. And either of those are okay. And the MyMathLab program probably has a specific way that they want you to enter it, so you should read that on what they have. Okay. Part C here, any x values for which f of x is equal to 3. So again, this is y is equal to 3. Before I do this, let me make the point that I was going to make. So the difference between listing the domain here and listing the domain here. So the domain here was just singular individual points. There was no continuity between, there was no line connecting these things together, which is why in our domain we listed these as individual points. Okay. The reason that we don't do that here is because this is, every single point, when you draw a line like this, every single point is included in the graph. And so, if you think about trying to list every point between 0 and 1, for instance, you can't do it. There's an infinite number of points there. And this is why we will use set notation and inequalities generally to be able to list these kinds of things if there's a restriction. There's no restriction here, so it's just all real numbers. Okay, so that's the difference in those two problems. All right, so now for y equals 3, we want to find the x's that go with y equals 3. So y equals 3 is right here. And if we go over, we find this point right here, which is occurring at x equals 3. But then there's also, there's also another point out here. And I believe I copied that one correctly from the graph. That's occurring at a positive 9. Okay. So we get x equals 3 and x equals 9 here for a y coordinate of 3. All right, and now we're identifying the range. So with the range, you're thinking the y-axis, you're thinking the y-coordinates. And if we look, we have graph basically here it's starting at y equals 0. So this is y equals 0 right here. And then we have graph everything above that. So you can see that our graph is going off towards infinity in this direction, infinity in this direction, and that's all positive y. So that's going out towards infinity for the y-axis. Notice that we don't have any graph down here. So we need to restrict this. So the way that I'm going to list my range here is y such that my y-coordinates are greater than or equal to 0. And this is what I was referring to a minute ago. The use of the inequality symbol here allows me to include all values that are equal to 0 or greater than it. And I don't have to list them individually because I can't list them individually. This is an infinite number of points here. Okay. The reason for the cutoff at 0 and the fact that we're above 0 is because that's where our graph is existing. It's existing in this region, not in this region. Okay, and in terms of how the y-axis flows, it goes off towards positive infinity up here and down towards negative infinity down there. Okay, and that's it for these problems.